What's going on, guys? Today we're going to be covering our aluminum donuts that we offer. Every time that I've posted about them, we get tons of comments and questions asking, what are they used for? Why are you using them? And in what situation would you need to use that versus a mandrel bent piece? So we're going to go over that today. We're going to cover a few things like what you receive when you order a donut from us, comparing them to mandrel bent pieces, and why that these might be beneficial in your next build. So let's go ahead and get into it. So first of all, we offer 4 different sizes for our aluminum donuts. We have a 2.5 inch, a 3 inch, 3.5 inch, and a 4 inch outside diameter. Each wall thickness of each half is roughly 70 thousandths thick. They come with a machine brush finish on each piece. And when you order them, you're going to receive 2 halves just like this. We sell them in a pair. Now, when it comes to assembly, the easiest way to assemble these is to typically tack 4 corners. So you'll just do it almost like in a plus symbol, and then put them on a positioner and then just weld. Now, you don't necessarily need a positioner to weld these. It just makes it a little easier. You can freehand them. It's just going to take a little bit more time. All right, so now why? The main reason why you want to use an aluminum donut is because if you're working in somewhere where it's a tight area, for instance, say between a throttle body and a radiator, where you only have a few inches of room to make a 90-degree bend off that throttle body to run the charge pipe straight down. Well, if you use something like this, which is a typical 90-degree mandrel bent 90, this is a 3 inch outside diameter. So if you have a throttle body here and your radiator is here, you can see that that bend is going to hit the radiator before it makes the gap that it needs to go in. So by taking our aluminum donuts, after you weld them in half, you're going to have something like that. And as you can see, if you compare this, which is a typical mandrel bent 90. Now we get all our 90s, all of our materials from Ace Race Parts. Great material. But so this is a typical with a 1.5 inch centerline radius, and this is with the same diameter, but using our aluminum donut. So as you can see, the clearance that you're able to achieve with a tighter radius donut. So this is going to help you get that extra room that you need. Now, this piece you could see is clearly not a 90 directly. It's a little bit more, but it gives you a good general idea. Now, what I feel is even more drastic is a 4 inch. So this is a typical 4 inch 90, again from Ace Race Parts. Here's where your bend starts, and then about right here is where your bend ends. But we don't have to worry about this extra leg. So as you can see, if you take a 4 inch donut, compare that to a 4 inch 90, you can see how much tighter of a radius that is, and how much room. That's probably going to give you almost 2.5, 3 inches more room compared to a mandrel. Now another plus with these donuts. So after completely welding the outside, this will actually give you 4 90s out of 1 piece of material. So you could cut 4 tight radius 90s out of this for roughly about the price of 2.5 to 3 inch 90s that are mandrel bends. But these are going to give you a much tighter radius than you are going to be able to get with a mandrel bend. Now, another thing that you need to know is after welding the complete outside and then measuring all your degrees that you need to cut, after you cut, then you're going to have to go back and you're going to have to weld the inside of that donut before making your welds on wherever your pipes are going to go. Now, maybe you're wondering, okay, so that works great for a 90, but what other degree would I need an aluminum donut for? There's no reason that I need to have a 45 out of this, or maybe even like a 22.5, when I can just take a 45 mandrel bent piece and I could cut it directly in the middle, and that would give me like 22.5 degrees. Well, that is true. It will get you that 22.5 degrees, but one thing people overlook is whenever the mandrel bent process happens, the aluminum is stretching. So your outside is actually going to be stretching, which is going to make the outside diameter the outside wall thickness much thinner than the inside wall thickness. So, for instance, this is a piece of 2.5 inch mandrel bent 90. As you can see, it was just like that. Now again, this is from Ace Race Parts. Now, if you take, we have some dial calipers here. If you take and measure the inside of that, you're going to get roughly 85 thousandths. Now this is going to vary throughout the piece, but this is just a general idea. So that's going to give you roughly 85, 86 thousandths on the inside wall thickness. Now, let's check the thickness of the outside wall thickness. 47 thousandths. So you're talking half the thickness on the outside wall thickness than the inside. So what's going to happen is if you have this, this is going to be a 45 degree right here, and you weld it on a piece of straight, something that hasn't been cut. So you know that the wall thickness is equal all the way around. When you go to weld that, and say you start on the thicker part. So you're like, okay, well this is working out great. I know my wall thickness is roughly about the same. And by the time you get around to where the outside of that bend is, your weld is just gonna go to crap. I mean, your heat is already starting to spread throughout the aluminum, as when you're welding aluminum, heat spreads really quickly. And you're just gonna wind up blowing a hole in this material because it's half the thickness of this. So you've already set your amps and your speed for what this wall thickness is, but by the time you get to there, it's gonna be half of that, and you're gonna be just in a world of hurt, and you're gonna be pissed off and chunking the material and wondering what exactly is going on because you overlooked that the thickness is different. With the donuts, you're going to maintain the same thickness throughout the entire bend. No matter if you cut this at 20 degrees or 50 degrees or 90 degrees or 180 degrees, it's going to be the same thickness throughout the entire bend as long as you do a straight cut. Now, when it comes to cutting, the easiest way to cut these is on a vertical bandsaw. You may be able to get away with it on an angle grinder, but it's probably not going to be a very clean cut, and you're going to spend a lot of time cleaning up just to get it to where exactly you want it to be. All right, so now let's go ahead and show you guys exactly on a vehicle why the 4-inch donut came in handy compared to a 4-inch 90. Okay, so here's an example on why you would need the tight radius donut for your build possibly. So here we have a LS twin turbo Silverado we just finished up with a Holley high ram, and it's using this throttle body adapter that we welded on the tight radius elbow and then welded on an HD flange there on the bottom. But as you can see, even with the stock fan shroud, we still have clearance between the 4-inch pipe and the shroud while still making that bend. Now, if we were to take the mandrel bent 4-inch 90 elbow that you can buy from various suppliers and put it where we would need it to clear the fan shroud, you could see how much further back this pipe would have to be welded on in order to make that bend straight down in front of the shroud. So we're almost behind the throttle body right at the intake, whereas with the tight radius donut, you're able to be, 3 or 4 inches further forward and still make that bend. So this is a perfect example of how these tight radius donuts can benefit you without having to do a ton of pie cuts in order to make this tight 90 or running like a 90 coupler. I hope this answers some of the questions that maybe you were having or wondering exactly if these might be beneficial for your next build. If this is something that you're interested in, you can head on over to oneupfabrication.com and place your order today. We have plenty in stock, ready to ship out next day.